Well, ladies and gentlemen, please give a round of applause in welcoming Tony Hunter.
Just be good to me.
10 billion. That's the number of people we're going to have on the planet by 2050. And all of them aspiring to eat the way they do in food-rich countries like the UK, US, Australia, and other parts of the world. How we feed these people is the question of our time. And I believe that we're at a once-in-a-generation crossroads. And the choices we make in the next few years are going to reverberate down through the decades. So what are the choices that we have in our crossroads opportunities, our choices? Well, the first one, of course, is business as usual. How about we just do what we do now and do more of it? But if you have a look at where we are with agriculture, over 50% of the arable land on the planet, in the red and the orange segments there, is used for producing food. And 70% of that is used in some way, shape or form by animal agriculture. Now, yes, we could do more of that. We could deforest the whole planet. I don't think that's going to end well. And water is no better. 92% of all the freshwater withdrawals on the planet are for agriculture. So we have some other options as well. Here we have the World Resources Institute, and they say all we need to do is just get people who eat too much to eat less and send it to the people that need the food. Now, I say to that, we've been telling people in food-rich countries like the US, Australia and the UK, eat less or you'll die of lifestyle-related diseases. How well's that going? Record levels of obesity, type 2 diabetes. I don't think telling people please eat less so we can send it somewhere else on the planet is going to be any more successful. Then we have the people who say, basically, just need to waste less. We make enough food on the planet to feed everybody, just waste less. And I think that reducing food waste is a very, very important thing to do. We need to maximize the amount of usable food from the food that we grow. My concern is that's simply not going to happen fast enough. And around about a third of all the food waste is in-home. So when it hits our freezers, our fridges, it gets thrown out in food-rich countries in particular. And an example of what happens is in the UK, under COVID lockdowns, self-reported in-home food waste dropped dramatically. But in 2021, when the lockdowns came off, guess what happened? It went back up to 2018 levels. So I don't think that reducing food waste is going to happen fast enough. I think it's going to take generational change to dramatically reduce food waste, particularly in home. So I don't think that's going to work for us. So what do we do? Well, I say that what we need to do is to reimagine the global food system using new technologies. So why technology? Well, you can't talk about food from farm to fork without talking about technology. Technology is everywhere in food. I mean, food used to be a sleepy backwater compared to industries like the electronics industry, but no more. Technology, as we'll see, is everywhere in food. That hasn't always been the case, though. How many people here get an industry newsletter on feeds? Put your hand up, you get an industry newsletter of some sort? Yep. I think pretty well everyone gets an industry newsletter of some sort. I certainly get my fair share. I probably got someone else's share as well in mind. But it was around about 2017 when I first noticed that things were really changing. I was seeing technologies I'd never seen before turn up in the newsletters. I was seeing technologies advancing far faster than I thought they could. So I dug deeper, and the deeper I dug, the more fascinated I became. And after 6 years of research, I've come to the conclusion that we're approaching the intersection of 5 exponential technologies driven by 3 accelerated technologies which are going to drive the future of food for decades to come. And that's why my choice at the crossroads for reimagining the future of food with technologies. And what are these technologies? They are alternative proteins, cellular agriculture, genomics, the microbiome, and synthetic biology. And these technologies are going to be driven by AI, quantum computing, and sensors, all leading to our exponential food future. Now, just qualify here that I'm not saying conventional agriculture, animal or crops are going to disappear. I mean, obviously not. But they will not have nearly as much influence on where the future of food goes as these technologies. And now, of course, you're wondering what the heck, or words to that effect, is a exponential food future? Well, it's built upon 2 key concepts. I said the first key concept is that food is now technology. They are so intertwined that you cannot separate out food at any level from technology. And our second key concept is that technologies advance exponentially. Now, who here has heard of Moore's law, the law for computers? So basically says that the number of transistors on a chip doubles every 2 years. And that's an example of exponential change in technology, a doubling over a time period. And that neatly gets me into my example here of technological advancement, exponential advancement. This is portable computing, 1975 style. Okay, my friend here, Mr. Gordon, has his hand on the first portable computer, the IBM 5100. Who would like to guess how much that weighed? Come on, somebody give me a number. How many kilos? It weighed 23 kilograms. Do not put it on your airplane tray table. It will not end well. And this machine, fully spec'd up, top of the range storage, top of the range memory, and a printer, some offline storage, cost the princely sum of $19,750 US in 1975, which is a staggering, today, $110,949. And the top of the range machine came with 64K of storage. Not even megabytes, so not gigabytes, 64K of storage. Now, my Samsung Galaxy Fold here, same size screen as there, comes with 4 million times the storage, at 1/1000th of the cost, at 1/100th of the weight in less than 50 years. 4 million times the storage, 1,000th of the cost, at 100th of the weight. That is the power of exponential technological change. So don't underestimate how fast things can happen. So putting these concepts together, where do they lead us? Food is now technologies advancing exponentially. You guessed it, food is now techsponential. And now that we've got our techsponential concept, how do we use that to reimagine the global food system? Well, the first thing we do is we use these technologies to equitably distribute the means of production, not the food outputs. So rather than saying, let's grow everything over here and ship it over there, we can actually do more localization of food production. And if countries want to reimagine their food system, then why should they simply duplicate everything that's gone before them? let's face it, our global food system does a pretty good job, but it's not without its problems. And the key problem we've got is we need massive resource inputs for our crops, and those massive resource inputs lead to pollution. And they lead to things like this massive dead zone in the Gulf of Mexico. We have a dead zone in Chesapeake Bay in the US. Even Lake Magadi in Kenya has a dead zone. And that's one of the downsides. And if we have a look at the consequences of COVID and the Ukraine war, we know how difficult it is now to get your hands on the nitrogen and the phosphorus that you actually need. And so the globalization of the food system, both in inputs and outputs, is really not the good idea that we once thought it was. So if these countries want to avoid these problems, what can they do? Well, I think that what they should do is something like what happened in Kenya in 2002. Now, in 2002, Kenya had one landline and 4 mobile phones per 100 head of population for 38 million people. As a comparison, Ireland had 77. So if they're going to grow economically, Kenya needed to do something. Now, you're going to have to use your imagination here, right? So let's pretend we're in the Kenyan cabinet. And, okay, cabinet. Now, we've got some telecommunications problems. Has anyone here got an idea on what we can do about it? Oh, you, over there. Yes, yes. What we're going to do, I think, I've done some research. What we need to do is we need to buy thousands of trenching machines. Then we can buy hundreds of thousands of kilometres of copper wire, fill in the trenches with them, then we can build exchanges, and then we can start a local landline handset manufacturing industry. What a wonderful idea. Hand me the landline. But who thinks, maybe it didn't quite go that way, but who thinks that was the outcome? Seriously. What happened was, of course, they brought in large telecommunications companies. They built cell towers. They gave the population cheap, basic, sometimes second-hand phones, and they leapfrogged 100 years of telecommunications technology in a decade. So why can't food countries that are developing their food system do the same thing and use the new technologies to leapfrog some of the old technologies that we're using and do just what Kenya did with telecommunications? Now, what are these technologies and how can they help to leapfrog the older technologies? Well, I'm only going to talk about 3 of them today. We're going to talk about alternative proteins, cellular agriculture, and synthetic biology. And the first one I want to tell you about is food from air. And this goes back to technology from the 60s, from the NASA. And basically what the company called Solar Foods does is they suck in air, they separate out the moisture, the CO2 and the nitrogen, they split the water into hydrogen and oxygen, they combine them all, process them all, and they use it to grow something called biomass. Now, biomass doesn't sound like much, but who's familiar with the dreaded Australian product Vegemite, the black paste? Basically, that is just biomass. So it's just microorganisms in, if you like, a lump. Imagine the yeast left after you make beer. That yeast is biomass, and you can restructure that to make alternative protein products. Then we have food from a volcano. A company called Nature's Find, they found at the bottom of the hot springs of Yellowstone National Park an organism that grows down there. And they've been growing that organism because it's very, very good at growing under very, very lean conditions, so it's very efficient. And they've used that to make cream cheese and even breakfast patties, hamburger patties. Then we've got food from wood. Now, when you cut down a tree to make lumber, you don't want all the branches. You don't want all the leaves. All you want is the trunk. What do you think happens to all the rest of the branches? Often they're simply burned. And that's not good for greenhouse gas emissions, for the planet, not a good way to go. And when you send that round log to the sawmill to make square or rectangular pieces of lumber, you got lots of offcuts and lots of sawdust. What do you think happens to those? They just get disposed of again, burned, buried, whatever. This company called Biome has found a way of using that wood as a feedstock for microorganisms to make, you guessed it, biomass again. And the good thing about that one was it's sustainable, it's recycling. We're not growing it just for food, we're using something that's currently wasted. Then we've got a company called Leafed, who are making food from leaves. Now, we all eat leaves now, of course, but the human digestive system can only extract a certain amount, a very minor amount of nutrition from any lettuce or bok choy or anything else that you eat. That's why cows eat grass and we don't. But the most abundant protein on the planet is called rubisco, and that is part of the photosynthesis cycle in green leaves. And this company's found a way of extracting that protein and then binding that together to make, again, alternative protein products, same as you would with soy protein or pea protein or anything else. And the future of any of these technologies is already here. These are cultivated meat chicken nuggets. Now, cultivated meat is where you take a few cells from an animal and you grow your meat in huge fermenters. So you grow them in stainless steel fermenters. You grow the animals or the parts you want without the animal. These have been on sale since December 2020 in Singapore, and they've just had approval of some chicken breasts as well that are on sale in a butcher in Singapore. So the future's here. As they say, future's here, it's just not evenly distributed. And this is a seafood product from a company called Wild Type. That is a cellular agriculture cultivated meat piece of Atlantic salmon from Wild Type. That's not a picture from the internet somewhere of what a piece of salmon looks like. That's the actual product. And you can also, if you want, just print the bits you need. Now, when you slaughter an animal, say a cow or a beast, you only get probably 65% yield. Then of that, you get another 63% yield. You only get 40%. A 1,000-pound animal will only give you 400 pounds of edible meat. So the theory here from a company called Aleph Farms in Israel is you 3D print the steak, and then you grow it so that it forms this steak. And I'm sure many of you, if not all of you, are thinking, Tony, that doesn't look exactly like a steak, right? Okay. But that is a prototype product from a year ago. Remember what I showed you with the IBM 5100? Imagine what that will look like in 5 or 10 years' time. I think you'll be challenged to tell the difference between the product, particularly in terms of flavor, taste, texture. You won't be able to tell the difference. And you can print foods that don't exist. Now, these things here are called omakase bites from a company called Stakeholder Foods. And what they've done is to print meat and fat cells in layer upon layer and produce this. Now, the closest we get would be a Wagyu product, but there is no way you are going to get that product from any known animal. So you can print things that don't exist, just the best bits that you want. And then we have, for the dairy industry here amongst you, milk without the mammal. You can take stem cells from milk, grow miniature mammary glands in stainless steel fermenters, specially designed bioreactors, and use those to make milk without the animal, without the mammal. And you can do that for any species, including humans. And this is a company called 108 Labs, and they are going to have their product on the market in the next few years. And just so you know that cellular agriculture isn't just all about animals, this is a company called California Cultured. They take cacao plant cells and grow those, and then they produce the components of chocolate like flavonols and other ingredients, and they can be used to make chocolate. Because the cacao plant has a lot of problems at the moment. Climate change, fungal diseases, all sorts of things are going on that are going to affect the supply of chocolate. And similarly, we have the same problem with coffee. the Arabica variety is not nearly as robust as, wait for it, the Robusta variety, and it has problems as well with climate change, disease, deforestation, and everything else. So a company called STEM is growing coffee plant cells, Robusta, Arabica cells, and then using that to make the ingredients to make ground coffee. And I'm sure you'll all be pleased, like me, that we're going to be able to eat chocolate and drink coffee for some time to come, whatever happens with the climate. And next we go on to synthetic biology. And believe it or not, the best example of synthetic biology is cheese, as some of you may know. Who likes cheese? Oh, a lot of takers there, love it. Okay, tell you how they used to make cheese back in the 80s, the old days. They took a 2-day-old dead calf, took out its full stomach, purified the inside to make rennet, added that to milk, curds, whey, curds, make cheese. Now, in the 80s, we find that cheese consumption is doing this. And they realised two things. One, not going to be enough dead calves around to make enough cheese. And secondly, for some reason, some people didn't like the idea of killing 2-day-old baby cows all the time. So our friends at Pfizer, who make the vaccine, they put the gene for one of the enzymes in rennet, chymosin, into a microorganism, and that microorganism makes the chymosin, and that's been used to make cheese. That was 1990. So in most industrialized countries, industrialized cheese processes use this fermentation-produced chymosin. So if you've been eating cheese for the last 33 years, if you've been eating it that long, you've been eating a food made with a product of a genetically modified organism. Now I ask my second question. Now I've told you that story. Put up your hand if you're going to stop eating cheese, or shout out, "No more cheese for me." Anyone? No, but it's GMO. I mean, it's a GMO organism. Why is nobody going to stop eating that because of that? So no one's going to stop eating cheese. And to get on to more recent times, in the similar vein synthetic biology, a company called Perfect Day has put the gene for whey protein into a yeast, and they make whey protein. They make ice cream, they make milk, make all sorts of things. Cool House ice cream. You can buy that in Singapore now. It's a food made with a product of a genetically modified organism, and they can't make enough of it and sell enough of it. They raised, Perfect Day, the company that makes this, raised $750 million to commercialize it. This is no little startup doing it in their garage, right? This is true commercial, massive scale production. And then when the cost of their whey protein is lower than that of cheese making from the dairy industry, then life gets very, very interesting. And we all know the problems we've got at the moment, particularly with the Ukraine war and avian influenza, that we've seen a huge shortage of eggs and egg products like egg white proteins. A company called the Every Company has put the gene for egg white protein, ovalbumin, into a microorganism, and they can make egg white proteins without the chickens. And another one on the dairy front is a company called Nobel Foods. They've put the gene for casein into soybeans. They grow the soybeans, they take the casein out to make cheese, and process the rest of the soybean. And they planted their first crops last year, and then have test products on the market this year. And just to give you another one, a little bit out there, egg white proteins again. How about putting the gene for egg white proteins into potatoes? A company called Polopo in Israel has done that. They grow the potatoes, they then extract the egg white protein, and they process the rest of the potato for starch. And with the current problems, the problem the poultry industry has is once a major manufacturer, CPG manufacturer, changes their supply chain from chickens to something else like this, the chances of them going back are very, very small, because this is a very stable way of producing it. It doesn't matter about avian influenza and chicken flocks or anything else. Price is much more stable. And back to synthetic biology, I mean, we've got a lot of people who are anti-GMOs, whatever GMOs are, a lot of people don't seem to know. There is no credible scientific information or research that says GMO products are bad for anyone. Contaminants like Roundup and glyphosate used, that's a whole different story. And many of you may be aware of the ongoing largest single trial of feeding GMO crops to animals. It's the 95% of all animals used for meat and dairy in the US that have been fed genetically modified feeds for many, many, many years. We eat DNA all the time. Every time you eat a piece of food, it's got DNA in it. But as the Food and Drug Administration in the US says, cows don't become grass and chickens don't become corn. So there is no problem with GMO products. If people have a philosophical disagreement, okay, happy to have that discussion. There's more I could talk about there. But anti-GMO sentiment is an existential threat to the future of food and feeding the planet. That's my opinion. And not to leave agriculture behind, a company called Pivot Bio, they make a soil microbiome that can reduce your usage of nitrogen by 40 pounds per acre. And you can imagine, with the problems at the moment of getting your hands on nitrogen, they're a very popular company. They've sold out every single year so far without any problems at all. And so, look, we've talked about a lot of technologies and really only the tip of the iceberg. But what we've got to realise is that all of these technologies are science fact. They are not science fiction. Now, some of these products are on the market now, like our Perfect Day ice cream, and some of them are going to take some years to come on the market. Some may take a decade or more to come on the market. But all of those technologies are here already. But the most important thing to remember is that these technologies can help us reimagine the global food system and avoid many of the problems that we've talked about with the current global food system. And that's that they use less resources, less input intensive, less pollution. If they localize production, then that means that there's less opportunity for supply chain disruptions and waste. Also, if we look at localized production, it'll increase food sovereignty and food security and probably stabilise prices. And last but by no means least, they enable us to get away from what I call the twin tyrannies of food production. The twin tyrannies of food production are arable land and fresh water. If you have lots of arable land in your country, lots of fresh water in your country, you have lots of food. If you don't, you don't. So that is why I call those twin tyrannies of food production. And for all of you here, what do all these technologies mean for animal agriculture? Who's heard the stories of Technology X will destroy animal agriculture within the next 10 or 15 years? Who's heard those? Huh? Anyone think they're not going to have a job in 10 years if you're in the animal agriculture industry? No, neither do I. So let's have a look at it. Cultivated meat, for instance. It's been estimated that if you want to replace 10% of the global meat production in 2030 with cultivated meat, where we take the cells and grow them in huge fermenters, it will cost $1.8 trillion US dollars. Now let's suppose we do lots of optimization, and it's only a mere trillion US dollars. That's 125 billion US dollars of capital expenditure every year from this year to 2030 inclusive. Now that's not going to happen this year, that's for sure. I don't see it happening next year or even the year after. We could be looking at 250 to 300 billion dollars of expenditure needed by 2029, 2030 to achieve that goal. I simply don't see it happening. And similarly, a lot of these other technologies will need massive capital expenditure to realize their potential and let them contribute significantly to the global food system. So I don't think anyone here should rush home and send their resume out to get out of the animal agriculture industry. But the thing that we need to look at is we need 50 to 70% more food by 2050, protein and other foods, if we're going to feed our 10 billion people. Now, I don't see that coming from animal agriculture. I don't see us being able to basically grow 50 or 70% more protein and foods by simply doing more of the same. I mean, we could just chop down the entire Amazon, get rid of all the rainforests and forests in Thailand and grow more food, but I don't think that's going to end well. I think that could be a very bad outcome. So we are going to need new technologies if we are going to sustainably and equitably feed our 10 billion people. But it's going to take time for those to scale up so that they can make a significant contribution. So it's not about destroying animal agriculture. But I think one thing that everybody here needs to ask themselves is, what business are you in? I mean, that may seem a fairly obvious question as to what business are you in, but I think you need to ask that yourself. If you say you're in the business of supplying X, Y, or Z for animal agriculture, you're tied to the fate of animal agriculture. If you say, I supply X, Y, or Z to grow proteins for humans, then you're always going to have a business. And that's what I said in an article I wrote after a conference here in 2019 in Bangkok, a feed industry conference. And about 6 months later, a company many of you may have heard of called Nutraco announced that it was providing growth culture media ingredients to 2 cultivated meat companies. Blue Nalu in the US making cultivated seafood, and Mosa Meats in the Netherlands making cultivated beef. So they are hedging their bets. And there's nothing to say that if you're in animal agriculture, you can't have a foot in both camps. And probably having a foot in both camps is the best insurance you can take out whatever happens in the future of food and the future of protein. So the reimagining the global food system is not about eliminating animal agriculture. It's about how we fill the gap between what's sustainable and possible within planetary boundaries using the conventional animal agriculture system and the growing food needs of increasing population and middle classes. And we've got to look at how we do this. And I think that my obvious choice here in the crossroads is that we take the view of reimagining the global food system using technologies. I don't think business as usual is viable. I don't think that reducing wastage is going to happen fast enough, but it's a good thing to do. And I don't think that telling people to stop eating so much and send it somewhere else is going to work very well either. So I think that what we need to do, we need to reimagine the global food system if we are going to sustainably, equitably, and healthily feed 10 billion people. The problem, someone calls it, of 10 billion people. But I say, let's not forget, the world's biggest problems are also the world's greatest opportunities. And we're going to have 10 billion opportunities in 2050. And I think our obligation as the food industry is to reimagine the global food system so we can sustainably, equitably, and healthily feed these people. And in the process, we will invent the future of our planet. Thank you.
Well, thank you very much, Tony Hunters. Dear all the participants, I'm sure that you would like to talk by face-to-face with Tony, but before that time, we have a special book we'd like to take away, to give away to our guests. How?
Oh, yes, so I brought with me 5 copies of a book. I'm a contributing author to a futurist book which talks about reimagining the global food system. I've got 5 copies with me. Anyone who's interested in a copy, come and see me.
Well, may I escort you to stand next to your book? Okay. Our team, we would like to give away to who really intense. Would you like to ask a question? Well, Tony, there's a lot of fans who would like to have your copy of your book. Okay. Could you please ask any question? All right. we would like to know your feedback after you learn more about this technology from Tony. Yeah, please, welcome. Would you like to say something? Yeah, okay. I can go ahead here. Hi, welcome to Web Square. Would you like to say something to Tony?
Thank you for this excellent presentation. I would like to ask your opinion on what will happen in tropical climates if they will catch up with the speed of this change in the food redistribution and everything you've spoken.
Look, I'd like to think so, but what's happening in a lot of countries is they're looking at the history of what's happened in the global food system in countries like the US and Europe and so on, and they're not seeing these new technologies as a viable alternative in the long term. So rather than looking at the Kenya effect, as I call it, and saying, why do I need to go through all this and build an entire industry when I've got other options? And I think that's the key thing that I'm seeing. There's not enough attention being paid to some of these new technologies. So I think that that's a great opportunity. I hope that people look at it and take it seriously. Thank you.
Thank you. Could you please go to the stage and be received the book from Tony? Hi.
Just one more. Yep.
Hi. Two questions, really. What do you think is the greatest barrier to the speed of adoption that you're imagining for this? And secondly, just one challenge maybe on the numbers, in that if you think of that $19,000 portable machine to the cost today, do you think that the advancement in the cost reduction will not be faster than you're imagining?
Well, I think the biggest barrier to me is regulation. Because we used to be, you could see a technology coming, it's 10 years, it's 5 years away, look, we've got time to think about it, let's think about it. Now, there's a product on the market that didn't exist 12 months ago and they want the regulators to approve it. And it's just, the regulators and government bodies are dramatically underfunded, under-equipped to deal with these new technologies. And I think that could be a major barrier to some of these technologies. Others, with GRAS, generally recognised as safe legislation in the US and so on, but I think we could have some problems there. Cost reduction. The rule of thumb in the futurists is people overestimate how quickly it will happen and underestimate the impact. So people in 1975 really didn't think that these things would exist. Oh, and by the way, they make phone calls as well. They're not just a computer, and you can watch cat videos as well. I mean, it's fantastic. So I think that's the thing, that how long it will take to reach that inflection point where the technology will really take off is the unknown quantity. How fast will it take off? But once it does, and one of the other examples I use of exponential growth is COVID. If you think COVID infections are 1, 2, 3, 4, 5, and they're 1, 2, 4, 8, 16, you're out by a factor of 3. One more doubling to 6 and 32, you're out by a factor of 5. So if you think linearly and the technology kicks up exponentially, you're going to be very, very far behind very, very quickly.
Excellent. Tony, could you please hand on your booklet to your fans and our audience who asked a question to you?
If you'd like it signed, I can sign it for you later. Let me know. Look.
Okay.
That's right. I think we have to pose for the picture. Oh, good. Thank you.
Well, we have more questions from the floor. We'd like to ask you.
Yep. Go
Hi.
ahead.
So I guess one of my questions is that one of the biggest pushbacks you get when it comes to food comes from the wellness industry.
Yep.
And a lot of it is like they'll quote or misquote different studies or different references. Do you have a specific reference that you like when it comes to GMO food or anything when you want to address or dispel those notions?
Look, I suppose my background's food science and technology, so I generally go straight to the papers and read those and see what's going on. There's the Genetic Literacy Project. They are very, very good. And they say We're talking about genetics, and we are talking about the facts that are there. So the Genetic Literacy Project, I think it's geneticliteracy.com or something silly like that, and you can go there and you can look at those. And when I look at the inconsistencies of anti-GMO sentiment, they are anti the perfect day whey protein in being used in dairy products. They didn't mention the GMO manufacture of chymosin to make cheese because they would lose so much credibility, it's not funny. So I find the whole thing rather hypocritical. Look, and I respect people who philosophically say we should not do this. That's a whole different argument, right? But don't try and tell me there's science involved in that. Philosophically, there's a difference. But I just read the other day, who likes sweet potato? I like sweet potato. Sweet potato is a genetically modified crop and has been for 8,000 years. It was genetically modified by a microorganism called agrobacterium, which has inserted its own DNA into the DNA of sweet potatoes. So we're already eating GMO crops, just not made by humans.
Well, thank you. That's very helpful.
Well, the last question from the floor.
One more.
Hello.
Yeah, okay.
Yeah, my question is again related to the GMO crops. One hand, we are saying that most of the world populations now asking for a organic milk or a antibiotic-free milk. And in GMO modified crops, you already told that the agrobacterium is the major impact. So to cope up with the challenge of this climate change impact, to fight or combat with the pest and disease, whether GMO is the final solutions in front of us?
Yeah. I think without genetic modification or genetic editing, that we face an uphill battle with our foods. I mean, the papaya was saved by genetic editing. We wouldn't have papayas in the world anymore if we hadn't genetically modified them. Cotton, not a food crop, but genetically modified. And again, the biggest feed trial of genetically modified food on animals is feeding all the animals, 95% of them, for meat or dairy in the US. Don't you think that if those GMO crops were causing all these horrible problems and cancers and affecting animals and everything else, we'd have heard that by now? We would have the animal industry up in arms telling everybody, get rid of your GMO crops because it's causing cancer in my animals, it's causing nutritional defects, it's causing all sorts of problems. Stop it. They're not saying that at all. So I think, to me, that's the biggest feed trial and the biggest proof that GMO crops don't harm animals.
Thank you. Thank you very much.
Thank you very much for the questions. Could you please join us on the stage to receive the booklet from Tony Hunter?
Thank you. If you'd like me to sign that?
Yeah.
Oh, just let me, I'll just go and grab my
As for
glasses
Viv
so I can
Asia
see
and
what
Mid
I'm doing.
Asia
I'll be back in 1 minute.
2023, we would like to thank you to our speaker, Tony Hunter, for sharing your unique perspective on the future of food. It is shaped us by his distinctive combination of scientific qualification and business excellence in deep understanding technology. Well, everyone, can you allow me to introduce to all of you about our coming up next program? We'll proceed here at Web Square, 2 p.m.